Today we are going to cover the first derivative in the shape of f, and really the primary thing that we're going to be focusing on here is going to be the first derivative test, which is going to help us identify local minima and local maximum. So let's see what we have here first. This first part's actually technically review increasing and decreasing functions. You all know if that first derivative is positive, then f is increasing. And if f prime of x is less than 0, we know it is decreasing. And before we get into the first derivative test, what that is what I'd like us to do is just determine where f is increasing or decreasing. Okay. And here is our function that we're going to try this out on. It's g of x equals 7x plus x to the minus 1. And so what we're going to do is we're going to start off with that derivative, because that's what we need in order to know whether it's increasing or decreasing. But there is technically something important here to think about. So this little, what we wrote right here was dependent technically on a couple things. We needed f to be continuous. And so I want us to just note that it is not continuous at x equals 0, right? If you have 0 to the minus 1, that's going to be 1 over 0 to the 1, which is undefined. Okay. Next, we'll go ahead and we'll take that derivative. Looks like we get 7, and then x to the minus 1, well, that's going to be minus x to the minus 2. And now if we want to know where it's increasing or decreasing, is what we're really asking ourselves is where is the derivative positive and where is the derivative negative? Okay. So if you're trying to find where it's positive and negative, it might help to find the points where it switches from positive to negative, or at least potentially switches from positive to negative. And when would that happen? Well, that would happen when the derivative is 0, right? If the derivative is 0, then there's a possibility that the sign of the derivative has changed from positive to negative or negative to positive at that point. So let's go ahead and do that. We'll just set this thing equal to 0. We could add this x to the minus 2 over. And then we could actually even multiply both sides of the equation by x squared. If we did that, we'd get 1 is equal to 7x squared. And then we could divide each side by 7, and so we get x squared is equal to 1/7. And we're almost there. Okay. We have one more step, and that is to use the square root property. And this gives us x is equal to plus or minus the square root of 1/7. Okay. Or the square root of 7 over 7 if you rationalize the denominator. Okay. So we have two values here where the derivative is 0. Okay. Now, it's not a bad idea to also think about locations where the derivative does not exist, okay, or where g is not continuous, so that'd be 0. And so is what this does, combining all these points, you go ahead and write them in. Is it splits our interval, our real number line, into multiple segments here. And the one in the middle, let's call that one x equals 0. And the other two, what we have, x is equal to 1 over the square root of 7. And the other x value is minus 1 over the square root of 7. Now that you can see we have our number line here and it's labeled, I want you to think about the points that we chose to put on the x-axis here. And the points that we chose to put on our number line here are really specifically the ones that either our first derivative, which is actually going to be g prime, is equal to 0, or g prime of x does not exist. Okay. And the reason that we've chosen these points are going to be the points where it's not increasing or decreasing. Okay. In fact, a lot of times, not always, but a lot of times when your first derivative is 0, oftentimes that's actually going to be a local maximum or a local minimum where the graph is neither increasing or decreasing. Okay. So that's really what we've done here with both of these, is we put down the points where it's not increasing or decreasing. Now, to figure out what is happening in each one of these intervals, there's 4 of them, we're going to need to plug in really test points. Okay. Let's go ahead and do that. I'm going to call them that too. Test points. So let's maybe start off here with one here in this leftmost interval. So we just need something that's less than -1 over the square root of 7. And I can think of an easy choice here. How about x equals -1? Okay. If we were to take that and plug that into our first derivative, we're going to get 7 minus, and then that's -1 to the -2. And if we were to rewrite this, or actually even just take -1 and raise it to the -2, that's actually just going to be 1. So this gives us 6, which is a positive number. So what that tells me is over this interval, it's increasing. G is increasing there. On our next interval, we need to choose a x value in between -1 over the square root of 7 and x equals 0. I think an easy choice here, maybe how about -1/7? Okay. That's in between those two. Or 1/10, just something in between those two. So g prime of -1/7, and this should be equal to 7 minus -1 over 7 to the -2. Okay. And keep in mind, we will be squaring this, and we have this to the -2, so this is going to look like 7 minus, and so this -2 is actually going to flip this over so that it's a 7 over 1, and the square itself is going to make it so that it doesn't matter whether this is positive or negative, right? If we were to square a positive number or a negative number, both wind up being positive. So this looks more like this. So we end up with 7 minus 49, which is negative, right? We don't even actually care what this is precisely equal to. This is less than 0. So over that other interval, it is decreasing. And next, in between 0 and 1 over the square root of 7. And how about we also do the same thing, but we'll use positive 1/7 this time. So we'll get g prime of 1/7. And this is actually also going to be equal to 7 minus 49, which is less than 0. And so it's decreasing there as well. So it's not always going to switch between increasing and decreasing with every consecutive interval. And then let's test out this last one. So let's try and plug in maybe 1. So we have x equals 1, g prime of 1. Well, that should be equal to the same thing as g prime of -1 because we're going to square the 1. So this just winds up being 6. And you can test that out, which is greater than 0. And so this function is increasing on this interval. And so what we'll do is we will record what we have here now. So we have that g is increasing on what appears to be minus infinity to -1 over the square root of 7 and, or union, 1 over the square root of 7 to infinity. Okay. So there's part of the question. And the other part is where it's decreasing. So g of x is decreasing on, and if we look up at those intervals, it's actually one big interval. At least at first it appears to be one big interval. But remember, at x equals 0, right, the derivative actually does not exist, right? It'd be undefined if we let x be 0 here. So we actually do need to keep this as two separate intervals. So this is going to look like -1 over the square root of 7, comma, 0, union 0, comma, 1 over the square root of 7. And what I'd like us to do now is check to see if the graph and our work correspond. So in other words, let's graph this and we'll see if it's actually increasing and decreasing on these corresponding intervals. Now that we're on Desmos here, we have our curve g of x plotted, the 7x plus x to the -1. And actually, I've also included the points that we found, right? X equals 1 over the square root of 7 and x equals -1 over the square root of 7. We found those were the points where the graph switched from increasing to decreasing and decreasing to increasing. Let's go ahead and take a look. I'm going to go ahead and put both those points on the curve. And so now you can actually see, if I zoom in here at least a little bit, you can see it is increasing from -infinity to x equals -1 over the square root of 7. And after we get to this point, you can see it's decreasing, which matches our work. And at x equals 0, right, the function's undefined. So we're not even going to talk about it increasing or decreasing there. And then here's the second half of this, and you can see that from 0 to 1 over the square root of 7, it's decreasing, and after that, it's increasing. So this looks good. This matches our work.